Okay, so for those of you who have just joined, just to let you know that I will be recording this session and then I will be uploading them on YouTube. So that doesn't mean that you can sleep or leave me behind while you do other stuff. Okay, so let's start with question 13. Question 13 says that we have a compound with molecular formula C4H8O, and it can have different functional groups and show different types of isomerism. The carbon chain is unbranched and the molecule is not cyclic. So that's our first hint. Unbranched means they are all in a straight line. Okay. And then the molecule is not cyclic. This is a cyclic molecule, and it's not that. No oxygen atom is attached to any carbon atom which is involved in pi bonding. So that means you do not have an oxygen next to a carbon with a double bond. So that means you don't have this. Okay, no oxygen atom is attached to any carbon which is involved in pi bonding. This is your pi bond. When compound H is reacted with sodium metal, a colorless flammable gas is produced. So this is actually a test for alcohol. So that's not something that you have done already, but I'm telling you that now. Both J and K give an orange-red precipitate when reacted with 2,4-dinitrophenylhydrazine. So we call that 2,4-DNPH. That means J and K contains the carbonyl C-double-bond-O. But only K reacts with Fehling solution. So Fehling solution, so I used to have a student called Paling, and we used to change Fehling solution to Paling solution. Anyway, sidetracking. So what this imply is that K is an aldehyde. Okay, so that gives you a hint already that J contains a C-double-bond-O, but it is not an aldehyde. So it must be the cousin, which is a ketone. Okay, suggest possible structure formula for H, J, and K. 3 structural formulas are possible for H, but only 1 for J and 1 for K. Okay, so the formula is C4H8O. Right, so how do we do this? First, H will be an alcohol. If you count the number of hydrogen for a straight chain alcohol, it will not be enough. For example, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. So that means there's something else. There is a double bond here. Okay, so the double bond, well, you have a few options where to put your double bond, of course, for H. Okay, so let me just, okay. So first is 1, 2, 3, 4. Remember that it would be a straight chain. First possible position of your double bond would be between the first and the second carbon. And don't forget to count that you have enough hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's missing. Eugene, what happened to Eugene? Okay. The second structure would be, of course, to move the double bond now between second and third. And lastly is to now move the OH group. Okay, so you may think that there are many more structures, but there are only just these three. So I keep the double bond between the first and the second. But now instead of putting the hydroxy group at the end, I now put it here. Okay. Now, why can't I put my OH here? Because it goes back to the requirement that was mentioned earlier on, that the oxygen cannot be attached to a carbon that is involved in a pi bonding. Okay, so I cannot put my OH here, nor can I put my OH there. So those are the three structures. It says to write down the structural formula. Okay, so structural formula should look like this. For example, H2C with a double bond, CH, CH2, CH2OH. Okay, so all your bonds will be hidden except for that double bond because it is a functional group. And make sure also you don't simplify this into C3H something, H6O. Okay, that's not a structural formula. Okay, so I'll let you finish off the three structures in terms of writing their structural formula. Please let me know when you are done. Okay. Ashikin, are you done?
Yes.
Okay. Because it seems that you're the only one who's communicating with me. But that's fine, because otherwise we will have a lot of background interruptions. Okay, moving on to J. I hope the rest are with me as well. Please just respond in the chat, or yes, you can momentarily switch on your microphone.
Yep.
We move on to J being an aldehyde, sorry, J being a ketone and L being there's no L.
K.
K being a ketone, no.
No.
Aldehyde, J being a ketone. Okay, so in this case, it's quite easy or straightforward because an aldehyde means you would need the C double bond O to be at the end. Okay, and then everything else just follows because it is a straight chain as mentioned earlier on. And for ketone, you write down the functional group first. Okay, so a ketone must be attached to two carbon. The C double bond O must be attached to two carbons. So you only have one carbon left. It doesn't matter if you connect it to the carbon on the left or the carbon on the right, it will still be the same. It will still be in the second position of carbon. So I will just add that. Okay, so 1, 2, 3, 4. Just make sure that you are counting the hydrogens as well, and they match with the molecular formula, which is C4H8O. In terms of structural formula for ketone and aldehyde, well, basically, I'm just giving you the answer here. It is written as CH3, CH2, CO. No, sorry. I'll follow my drawing. CH3, CO, CH2, CH3. Okay. I have one question I have one student ask me previously, why don't we show the double bond? Good question.
Functional group.
CH2, CH2, CHO. Okay, the way we write the functional group for the aldehyde is CHO. That's just to differentiate it from alcohol, where we would write COH.
Mm.
Okay, great. Okay, please let me know when you are done. Okay, I also remember asking you to do question 14 last time, but I don't know if you did that already or not, but I'm just gonna go through it with you quickly because I don't want to leave that blank. Otherwise, in the future, I would think that we haven't done that question. Is that okay?
Yes.
Are we done here on question 13, part A? Hi, Ayman.
Hi.
Hi, man.
Gosh, Fab.
If
You
Am I still
switch.
loud?
Yeah.
Oh, hang on.
Okay, moving on. In addition to being structural isomers of each other, some of the possible structures for H, J, or K show cis-trans isomerism or are chiral. Okay, draw the displayed formula of those isomers which show cis-trans isomerism. So cis-trans isomerism is usually applicable for the double bonds. Okay, so you choose one structure from H that can give you a cis-trans isomer. So I will let you do that one yourself. Okay, that's that. And then draw the displayed formula of those isomers which are chiral, indicating in each case the chiral carbon atom. Okay, before I move on to the next part, part 3, I just want to give you hint when drawing the cis-trans isomers, always put the double bond as your highlight. Okay, and then everything else is just hanging of it. So this is the time for you to revise back, maybe not now, maybe later after class, to revise back on your cis-trans isomerism.
Yes.
Regarding your end of year exam, we don't have the final decision yet, but it looks like the admin still wants it to be on. Okay, but I will keep you updated from time to time. Okay, for part 3, one of them is chiral. I can tell you that the chiral center is also one of it from H. Okay, so that's a hint for you. Cis-trans is one of the structures of H. Chiral center also comes from one of the structures of H. Now, when drawing the optical isomers, okay, you have to draw it in displayed formula. That means you have to draw all the bonds, including your OH bonds. You must show oxygen, single bond, hydrogen. And even though it was not mentioned in the question, you have to draw the 3D drawing. Okay, and the reflection would be that. Okay, now because we are doing everything virtually or online, which I cannot possibly check your answer right now on the spot. And also, I don't want you to switch on your camera because I think that will affect the connection and the clarity of my screen as well. So what I want you to do is, after this, you will take a photo of your work, okay? And then you will upload it to your folder on OneDrive. So I have prepared a folder for each of you. You have your own individual folder. That's where you are going to upload your work or any work that I asked you to. Okay. Previously, I asked my students to send their photos to me on WhatsApp. And I found this to be really, really confusing. Okay, I got confused and I was receiving a lot of things and I don't know who it belongs to. Okay, if it is in your folder, then it's fine. It's just there. It's organized in one place. Okay, great. Okay, so I will leave you with that to do, to complete. Okay, just make sure you read the question carefully. If it asks for the displayed formula, I just noticed that the question in part 2 also require you to draw the displayed formula.
Yes.
So please show it, please do it. Okay, I don't want to draw it for you now because otherwise I will be giving you the answer, which structure has a cis-trans and which structure has an optical isomer. Do you need more time or can we carry on?
Miss, what does it mean by indicating each case the chiral atom with an asterisk? Where do
Okay,
we put the asterisk?
so your asterisk is here, where your chiral center is.
Yes.
Does that answer your question, Fab?
Yes.
Yep. Wait, hold on. Draw the displayed formula of those isomers which are chiral, indicating in each case the chiral carbon. Oh, so it's not asking you for the optical isomers, is it? It's just asking you to draw the structure that has a chiral center. So you just have to draw one structure. Is that clear?
Yes.
Let me know when I can
Move on.
move on. Yes, that's right.
I'm ready.
Okay, so I will check your answer later on when you have uploaded your photos. Someone gave me a thumbs up. Abby, thank you, Abby. Okay, question 14. Right, but(1-ene is an important compound. Some reactions of but(1-ene are given below. In each empty box, draw the structural formula. So again, something that you may miss if you read the question quickly, or if you skip the question and jump straight to answering. Okay, so the first reaction is here, producing compound T. Okay, so you need to familiarize yourself with the possible reactions of your alkenes. So you have H2O gas, that's steam, with a catalyst of a concentrated phosphoric acid. So this looks like it's a hydration. Yeah, hydration reaction. So
Yes.
hydration reaction, you will be adding water. Okay, I don't know if you remember this, but when you add water, you will add hydrogen to one carbon and OH to the neighboring or the adjacent carbon.
Right.
Or you can swap the position as well. You can add OH here and hydrogen to the first carbon, hydroxy to the second carbon. Now, which one is correct? Now, the more stable product is when you have hydroxy group on the second carbon. So CH3, CH2, CHOH, CH3. Okay, that's the second carbon. Now, that's not my structural formula yet. I'm just showing you where I am adding my hydroxy group to.
Yes.
Okay, so the structural formula is actually CH3, CH2, CHOH, CH3. Because the hydroxy group is a side chain. 1, 2, 3, 4. This is the more stable structure. However, of course, they also accept the other possible product, which is if you add your hydroxy group to the first carbon and your hydrogen to the second carbon, in which case the structural formula would be CH3, CH2, CH2, H2OH.
Yes.
Okay, so they accept both answer, either one. You just need to write down one answer. But I would go with this because it is a more stable isomer, or we say it's the major product. Okay, so you can add that for your future reference because this is something that we will cover in under the topic alcohol. And the other one is a minor product. For V, it's a reaction with acidified potassium manganate, cold dilute acidified potassium manganate. So this reaction is called the mild oxidation. The first reaction that we were looking at is called the hydration. of alkenes. Okay. So mild oxidation means you are adding. Okay, we have 10 minutes left, so we'll just finish this question. We are adding hydroxy group to across the double bond. So that means we have 1, 2, 3, 4. And your double bond is between carbon 1 and carbon 2. I usually like to label them so that I don't forget or I don't get confused. So you are adding hydroxy group to what used to be the double bond. So that's your carbon 1 and carbon 2. So you have a diol. Our product is called a diol. Question wants you to write down the structural formula. So to write down the structural formula, it's CH3, CH2, CHOH, CH2OH. Okay. The reason why we don't put OH in a bracket is because it's already at the end of the chain. So we don't count it as a side chain. Okay. So we see it as a part of the principal chain, so we don't have to draw the bracket for that. The next reaction is not something that you have done, so I will just give you the answer, but it is actually an oxidation of primary and secondary alcohol. So that's for your future reference as well. See, the answer for W is CH3, CH2, CO, COOH. Okay, so I will not explain that further. We'll keep it.
Miss,
Yes.
I think in our question, the answer's at the next page.
Ah, the answer is given.
In the next page.
Yes, miss.
Oh,
Yeah.
okay. You guys could have said something.
We only realized.
Oh, you just realize it now. Okay, fine. Okay, so then I don't have to go through you with you because you know the answer to you. Okay, compound T reacts with compound U. T is an alcohol. U is a carboxylic acid. Does anyone know this reaction?
Esterification.
Yes, good. Esterification. So I'll leave you.
Esterification.
Do you have the answer for this as well?
No.
No.
Okay, so that is something for you to do. Oh, okay. Is there anything else? That's all right. For question 14. Next one is question 15. Okay, great. Right, so that is all for today. We only have 6 minutes left, so I'm just going to stop the recording. Okay, so before I stop this, so what happens is that I want you to complete this question 13 and 14, and then submit to me online by uploading your photos to your individual OneDrive folder. So I will be sending you a text personally later with the link to your own folder. Is that okay?
Yes.
Okay.
Yes.
Any question before we go?
No.